let's look at inverse functions, okay? So here's our function in function notation, our function such that x is a variable inside of it. This f represents, like we said, it could be anything. It could be quadratic, it could be linear, cubic, it could be a root function, it could be absolute. There's so many different types of functions in mathematics, okay? So this represents all of them with these general rules. What we need to do for an inverse function, a lot of times an inverse function is represented as the function to the power of -1 over x. In other words, saying we've inverted the function. What is the inverse of this function? It can sometimes be hard to work with inverse functions when they're in what's called function notation. So we could kind of revert back to this being a y value, and I have y is equal to a f. I'm still going to use f to represent whatever it is. Okay. Inside we have k, x, and we're going to subtract d, and then plus the value of c. Okay. And what we're going to do from now on, I'm going to work in one color, okay, because that takes too long to do. But what we're going to do next is we're going to switch the places of the x and the y. We're going to use the inverse of them. So they're going to take up opposite points. So now the y is our new x, okay, is equal to a of a function, k, bracket, and now this is where the y is. Subtract d and the function plus c. Great, we've done that. If I actually typed that into a graphing calculator, it would graph the inverse function for me. But that doesn't make a lot of sense if I need to graph this by hand, because I'm used to graphing when a function is equal to y. That's how we're usually taught in math, to graph something. So I need to set this function back equal to y. Okay, so I need to start moving things around. So the first thing I'm going to move, okay, so we're going to get x. I need to move c over. And c will become what? Negative. Okay, so we now have negative c is equal to, I'm going to do it one step at a time for you guys, okay? I'm going to do everything. Y minus d, okay? Next thing we're going to move, we'll highlight it, is our a. And because this is multiplication, when I move the a over, what does it become? Everything becomes divided by, okay? So now we have x minus c. Oh, did I do it in the wrong color? I did. Minus c. Oh. Purple. There we go. Minus c divided by a is equal to, now this is the abstract part that's kind of confusing, is equal to a function, bracket k, y minus d. Now this is the part where we would do the inverse of whatever that function is. So if it was squared, we would square root both sides. Okay? If it was square rooted, we would square both sides. Okay? If it was, let's see, if it was cubed, we do the cubed root. I don't know if you guys have talked about that, cubed root of something. What else do we work with? Linear, it would be what's considered the inverse, so you just kind of, actually nothing would really happen here. Nothing would need to happen. Absolute value, what's actually an absolute value is abs to the power of -1. We don't talk about that. But what I'm trying to emphasize is whatever the function is, okay, this is where we do the inverse of that function. So square, the opposite is a root, root opposite is squared, and that's all we're going to really talk about. So the f, I'm just going to move it over, okay, and it's now technically the inverse of whatever it was before. So we have x subtract c here, all divided by, oh, purple, nice, divided by a. Okay. So we've now brought the inverse of whatever that was, and we're left with k y minus d. And again, this is really abstract because we're using all letters, but we'll do an example with numbers to tie this back. The next thing we need to do is I need to move the k value over, and because that's multiplication, we need to divide by it. Another way of writing that, though, is to multiply by the inverse of something. That's technically the same thing as multiplication, or sorry, as division of a number. So we have that same function, x minus c over a, I'll change all the colors at the end there, is equal to y minus d. And what does that d become? Yeah, it becomes positive. Okay? X minus c over a plus d is now equal to our y, or what's known as the inverse of the function. So, looks really weird. It's a whole bunch of letters. But if you recall from the original, this is the place value of an a. So your new a is whatever 1 over k of the old function would be. Okay. This outside here, where's my purple, is the place value of a c. Okay. And because d was negative, it's the opposite of what the d was. Our new c is the opposite of whatever the d was originally. Okay. Our d value is now the opposite of whatever the c was, and our k value, that can be written as 1 over a, okay, is now the inverse of whatever the a was. So everything has just been flipped around from where it was before. So I'm going to quickly do an example here. Let's say we have the function of 3 square root 4 x plus 2 minus 8, okay? And I want to do the inverse. Well, the inverse means I turn this into a y, and I now turn this into x. Okay. So we have x is equal to 3 square root 4 y plus 2 minus 8. I know there's a hard idea here. There's a lot of info in one sitting. We move the 8 over. We get x plus 8. So now the d value is the opposite of whatever the c was, is equal to, and I can move the 3 over in the same step. Because there's multiplication, we divide by 3. So we're now just left with, it's in purple, square root of 4 times y plus 2. This is where we stopped when we talked about we do the inverse of the function. Because this is rooted, we got to square both sides. So these cancel out, and this now becomes a function that is squared. So you have x plus 8 divided by 3 squared is equal to 4 y plus 2. We need to divide by 4. I'm just going to multiply by a fourth. It's technically the same thing. So I multiply by a fourth. It kind of creates a 1, or it cancels out, however you want to call it, is equal to y plus 2. And when we move the 2 over, we get 1/4 x plus 8. I'm actually going to factor out that 1 over 3, okay, so it looks like a k value, squared, and then minus 2. So what I did in that step is I just common factored out 1 over 3, so you could see it's the k value. And if I just change our view, we'll go up just a little to the original. Where's my zoom button? Let's go to 75. There we go. I just want to draw your attention to 1 over 4, okay? Our new a value is our inverted k value. Okay. Our c value is the opposite of what our d value was. Our new d value is the opposite of what the c value was. And our k value is the inverse of whatever the a value was. Okay, so for our inverse functions, just our letters kind of switch places and our values become